system instead, and then do some post adjustments to it. That's kind of what happened on the equilibrium projects, which I'll talk about as we go through this presentation. So there are some things you can do, either post-processing or adjusting inputs to make it work. And as far as simpler programs go, there isn't really very much.
Yeah, no, I'm not thinking simpler. It's something that would be actually
more complex.
More complex.
The Department of Energy in the States has one that they call Energy 10, I believe. It runs an hourly model, so it has similar inputs, but runs it in much finer detail. And I haven't actually used it because we tend to, it's much more about 2000 I've been using. And then for commercial buildings, there's also EE4, which is an hourly simulation that's based on that. It's based on the same Department of Energy engine. And that's, so there's basically the two that I'm aware of. And I'm not sure what there is in Europe. And no one elsewhere.
All right, well, we'll start with this one.
For most of what you need in residential, POT 2000 is quite sufficient. Red Screen is another Government of Canada product. Our taxpayers pay for it. Our tax dollars pay for it. It is actually designed to be a financial tool, is what it's for. Now it has a little bit of sort of description of the energy system that you develop as well, that uses the similar weather data to what POT 2000 does. So you can just ignore the financial stuff and use it as an energy simulating tool. It again does a monthly balance, so it's not. It has those same limitations that POT 2000 does because of that. Because it doesn't have that finer resolution. But it works in a similar manner. You take the inputs of whatever it is you're trying to, or the characteristics of whatever it is you're trying to do. So if it was a wind turbine, it would be a park, or if it was the solar thermal system, it would be the tau alpha and the size of the tank and those kinds of things. And it takes the weather and then does basically an energy balance again on that system for each month. One of the things that the red screen models have shown, especially in wind turbines, is that it assumes 100% availability of the equipment for the entire year. In the case of wind turbines, it doesn't go well, and PV systems as well. It doesn't include shading, windbreaks, trees, turbulence. It assumes for wind turbines you've got open field, perfect wind conditions. It assumes for PV systems that you've got no shade, no dormers, no any of that kind of stuff. There is factors you can adjust, that you can put in to adjust, but you have to be able to take that information that you know about the site and turn that into a factor that you can then put into red screen. But you only have one factor. So if it's shading, for example, the factor is going to be different in the summer than it is in the winter, which means you can't handle snow cover on PV panels or solar thermal panels. You don't do that either.
You can do monthly factors.
You
So like you can be rate. So lots of times, if I do a relatively flat roof, I'll say, yeah, you're only getting 10% in December, January, February.
in red screen 3 you can. Red screen 4 you can't.
I think you can.
Yeah, I haven't
On the solar thermal, I don't know about the PV.
Okay. Yeah, 4 was a step backwards as far as I'm concerned. I used 3.
Okay.
Because 4, in order to simplify it, they've taken away too much information, I think. So this is the modeling for one of the equilibrium houses. This is the combination of the Hot 2000 data and the rescue data. So the other thing that we've done with this one is this is actually the history for a given year. So you'll notice that October, the energy use is higher and the energy production is lower. And that's because October was colder and darker, less sunshine. So we've adjusted the model output to match the real weather conditions for each of the months in this particular model. So we've done some post-processing history to get this model. This is what our prediction is, looking backwards, of what this house should have looked like when we measured it. Typically when we measure them, solar thermal production especially is much lower. PV production is close to what red screen predicts. And energy use, space heating is often similar. Appliance energy use is all over the map. It really depends on what people put in their houses. So I thought I'd talk a little bit about equilibrium housing project, just to kind of give some context to talk about some of the other things. And I'm just going to kind of plow through these next 30, 40 slides really quickly. So if we want to run across something, just stop me and ask. Run across something you're interested in. So Ecoterra is where I'll start. It's a house in Eastman, Quebec. It was a factory-built house. So it was built in 7 pieces in a factory and trucked to site and assembled. It's on a big lot in the middle of nowhere, so they were able to orient it directly south. It has a ground source heat pump as well as a building integrated photovoltaic thermal system. So the upper roof there is actually solar panels. It's got the unisolar thin film panels on it. Underneath the thermal part of this, they pass air under the roof, under the panels, so it heats up and cools off the panels at the same time. So you get that that little more efficiency from the cooler panels, and then they bring that warm air down and actually pass it through the basement floor. The basement floor is hollow core. So they heat the basement floor with the air that they recover off of off the underside of the panels. It doesn't run as much as they were hoping it would. Not quite as effective as they were hoping it would be. It's also got lots of passive features. It has a trome wall. Although it's not a trome wall straight behind the glazing, it's actually back in the middle of the room. So in summertime it actually shines on the wall. Or sorry, wintertime it shines on the wall. But summertime it wouldn't get anywhere near it. And then they've also got about 6 inches of concrete on the floor and behind all those big windows on the main floor. So lots of thermal vents. All of the equilibrium houses are, I shouldn't say all of them because there's a couple that aren't, but they are monitored by Fat Spaniel. So you can actually go to Fat Spaniel and if you search for CMHC, you can get a list of all the equilibrium houses, and you can get it live. Time for my ground source